Welcome to Financial Statistics. Today, we are diving into one of the most fascinating and powerful concepts in modern finance derivatives. Imagine you are planning a massive outdoor wedding 6 months from now, and you need to buy 1,000 roses. You are terrified that a sudden frost might destroy the local rose crops, causing the price of roses to skyrocket just before your wedding. How do you protect yourself? This is exactly where derivatives come in. They are the invisible plumbing of the global financial system, and by the end of this lesson, you will understand exactly how they work. Now that we have our wedding rose scenario in mind, let us define what a derivative actually is. A derivative is simply a financial contract whose value depends on or derives from the price of something else. That something else is called the underlying asset. This underlying asset can be almost anything: a stock, a barrel of oil, a foreign currency, or even the weather. If the price of the underlying asset changes, the value of the derivative contract changes right along with it. To put it in the simplest terms possible, a derivative is just a side bet or a side agreement about the future price of a real item. You are not buying the item today. You are just making a legally binding promise regarding its future price. Building on that basic definition, let us break down the four main types of derivatives you will encounter. First, we have a forward contract, which is a private, customizable agreement between two parties to buy or sell an asset at a specified price on a future date. Because it is private, it can be tailored to exact needs. A futures contract is very similar, but instead of being a private handshake deal, it is standardized and traded on a public exchange. Think of a forward as a custom tailored suit, while a futures contract is a standard size suit you buy off the rack. The third type is an option contract, which gives you the right but not the obligation to buy or sell an asset at a set price before a certain date. Finally, a swap is an agreement where two parties exchange sequences of cash flows over time, like trading a fixed interest rate for a variable one. Knowing the types of contracts naturally leads us to ask, why do people actually use these tools? There are three main purposes. The first is hedging, which means using derivatives to reduce or eliminate risk. It is exactly like buying car insurance. You pay a little bit now to protect yourself from a massive financial loss if you crash. The second purpose is speculation, which is the exact opposite. It means taking on extra risk to bet on the direction the market will move, hoping to make a large profit. A speculator is like a sports bettor who has no actual stake in the game but places a wager on who will win. The third purpose is arbitrage. This is the act of simultaneously buying and selling the same asset in different markets to lock in a riskless profit. Much like finding a rare comic book at a garage sale for $1 and immediately selling it to a collector for $10. To understand how derivatives work mathematically, we can look at the payoff of a simple forward contract. Suppose you take a long position, which is finance jargon for being the buyer in the contract. You agreed today to buy the asset later at a locked-in delivery price. When the expiration date arrives, your profit is simply the difference between what the asset is actually worth and the locked-in price you promised to pay. In this formula, P represents the payoff or profit of the contract. The symbol S sub T represents the spot price, which is the actual market price of the underlying asset at the maturity date, measured in dollars. The symbol K represents the delivery price, which is the locked-in price you agreed to pay. If the market price S sub T increases, your payoff increases because you get to buy a valuable asset for a cheap locked-in price K. If the market price drops below K, your payoff becomes negative, meaning you lose money because you are forced to overpay. Now that we have our formula, let us see how it works in a real-world scenario. A coffee shop owner is worried that the price of coffee beans will rise over the next 6 months. Today, she enters into a long forward contract to buy 1,000 pounds of coffee beans in 6 months at a locked-in delivery price of $3 per pound. After 6 months, a severe drought hits and the actual market price of coffee beans skyrockets to $5 per pound. We start by identifying the delivery price, represented by the symbol K, which is $3. Next, we identify the spot price at maturity, represented by S sub T, which is $5 due to the drought. Finally, we write down the standard payoff formula for a long forward contract, which is P equals S sub T minus K. This equation will tell us how much money the owner saved on every single pound of coffee. Continuing with our calculation, we substitute the known numerical values into our payoff formula. We replace the final market price variable with the number 5. We replace the locked-in delivery price variable with the number 3. This sets up the basic arithmetic needed to find her savings. Subtracting the values shows a payoff of $2 per pound. This means the contract saved her exactly $2 on every single pound she bought. Because the result is a positive number, it represents a financial gain or a successful hedge. She is effectively buying a $5 asset for only $3, completely shielding herself from the unpredictable drought that devastated the open market. To find the total payoff, we must account for the entire size of the contract. We multiply the per pound payoff by the total quantity specified in the agreement. The contract was written for a total of 1,000 pounds of coffee beans. This multiplication scales our unit profit up to the final total profit. The total payoff calculated is $2,000. Physically, this means the derivative contract acted as a perfect financial shield. It protected the coffee shop owner from the unpredictable drought and saved her $2,000 that she would have otherwise lost. She can now keep her coffee prices stable for her customers, proving exactly why hedging is so valuable for businesses. Having calculated a real payoff, let us look at how this behaves visually across all possible prices. The diagram you are seeing summarizes how a forward contract works. The horizontal axis represents the spot price at maturity, and the vertical axis represents your payoff. The point where the diagonal line crosses the horizontal axis is the locked-in delivery price, K. If the final market price ends up to the right of this point, the line goes up into the green zone, meaning you make a profit. This is exactly what happened to our coffee shop owner. However, if the market price ends up to the left, the line drops into the red zone, meaning you suffer a loss because you are forced to pay more than the asset is currently worth. While a forward contract forces you to buy, an option contract gives you a choice, which changes our math entirely. The payoff of a call option is the maximum of either 0 if you walk away or the market price minus the strike price if you exercise the option. In this formula, P represents the gross payoff. The mathematical max function means we must choose whichever number is larger between the two options provided inside the parenthesis. We compare the profit from buying at the strike price against a flat 0. We choose 0 if the market price is lower than the strike price, because a rational person would simply walk away rather than overpay. Finally, to find the true net profit, we use a second simple equation. P net equals P minus C, where C is the initial premium or fee you paid to buy the option in the first place. Let us apply this new formula to a speculator looking to make a profit. A speculator believes that the stock of a tech company, currently priced at $50, will rise sharply. He buys a call option with a strike price of $55, expiring in 1 month. He pays a $2 fee called a premium for this option. At the end of the month, the stock price is $60. We start with our standard payoff formula for a call option. We substitute the specific numbers from our problem into the option formula. The final market spot price of $60 replaces the variable S sub T. The option strike price of $55 replaces the variable K. We perform the subtraction inside the parentheses first. Subtracting 55 from 60 gives us a result of 5. We now must compare this result of 5 against the number 0. Continuing our evaluation, since 5 is strictly greater than 0, the maximum value is 5. The gross payoff of the option itself is therefore $5 per share. The speculator exercises his right to buy the stock at the cheap price of $55 and can immediately sell it for $60. This creates an immediate gross gain of $5. However, to find the actual money the speculator takes home, we must calculate the net profit. We do this by subtracting the initial cost of buying the option from the gross payoff. This initial cost is known as the premium, represented by the variable C. We substitute our calculated payoff of $5 and our known premium of $2 into the net profit equation. If we ignored this cost, we would falsely overstate how much money the speculator actually made. Completing our final subtraction, we find the final result. The final net profit is $3 per share. Physically, this means that by risking only a small $2 fee upfront, the speculator successfully bet on the market direction. He walked away with a positive return on his investment. This perfectly demonstrates how options can be used for speculation, allowing investors to generate large percentage returns from relatively small initial investments, while strictly limiting their potential losses to just the premium paid. We have covered a lot of ground today, so let us summarize the most important ideas. First, remember that a derivative is simply a contract whose value is tied to an underlying asset, whether that is a forward, future, option, or swap. Second, these tools are essential for modern business. They allow individuals and corporations to manage their financial exposure by hedging against risks, speculating on market movements, or finding riskless arbitrage opportunities. Finally, by understanding the basic mathematical payoff structures, you can see exactly how these financial instruments provide certainty in an unpredictable world. You now understand the invisible plumbing of the global financial system. Great job today.